Welcome to the Problem Solving in Algebra and Geometry page 27 video. A couple things to go over for page 27. The first is some of the interesting things that happen when you double a square. When you're looking at geometric properties of shapes, there's a big difference between the perimeter and the area and the volume. Let's take a look at these two squares here. The one on the left, each side is simply a length of 1, and the one on the length has a side of 2. So notice the side's been doubled. We'll the perimeter of the square with the length of 1 is 4. The perimeter of the square of length 2, count our way around, we would get 8. And you see when this happens, we have doubled the perimeter. We doubled the side length, and we doubled the perimeter. But it's interesting to see what happens with the area and the volume. The area of the side of length 1 is going to be 1 times 1 or 1, but with a side length of 2, 2 times 2 is 4. Right? Clearly we can see there are 4 square inches in that larger square. Well, notice here, we didn't double the area. We actually quadrupled the area, or multiplied by a factor of 4. If you think about the volume, this was actually a cube, so if we actually drew little cubes, now this is a 1 by 1 by 1 cube, length times width times height is going to give us a volume of 1 for this guy. But now this one, obviously even bigger. Now this is going to be all 2 by 2. And if you look at that carefully, length times width times height, 2 times 2 times 2 is going to be 8. So when we double the side of a square, if it were a cube, this is actually going to be increased by a factor of 8. And if you look at that close, you might be able to see a pattern. We don't really have a fourth dimensional cube, but if we did, you might be able to see that it would actually go up by a factor of 16. I don't know what that would be called, but it would go up by a factor of 16. The next thing to look at on this particular page is comparing fractions. Again, this should be some review. There's a nice problem that has you compare a bunch of fractions. 2 of them are 19/60ths and 33/100ths. Again, when you're comparing fractions, this can be kind of hard. It's not really readily apparent whether 19/60ths is bigger or less than 33/100ths. It's always helpful to have the common denominator. Once you have a common denominator, it's easy to compare the two. You can always find a common denominator by multiplying the two denominators together. That's probably won't give you the smallest common denominator, but it'll always work. We can do a little better here. Multiples of 100 would be 200. 60 doesn't go into that, but 300 should be good. So if I turn it into 300, remember all I'm going to do is multiply the top and bottom of the fraction by the same thing to keep the value. Well, 60 times 5 will give me 300, so I need the same to 19. 19 times 5 should give me 95. Here I've got 100 times 3 for 300. 33 times 3 is 99. Now it's obvious that 95/300ths is going to be less than 99/300ths, because we're talking about the same thing. I've taken this pie, broken it into 300 pieces. I'm giving you 95. On this side, the pie with 300 pieces, I'm keeping 99 of them. Obviously, I would get more pie than you do. But you just need to change it into a common denominator, then it's easy to compare the two fractions. Next topic is really helpful when it comes to graphing lines. And that's simply finding the intercepts, meaning the x and y intercepts of an equation. So if you picture a little graph, y on the vertical axis, x on the horizontal axis, and let's say we have the equation 3x plus 2y equals 18. Clearly this one is written in standard form. Obviously one way you could find the y-intercept is you could put that into slope-intercept form. You could do the algebra on that. That's fine, it'll work, but it's definitely not the most efficient way to find the x and y-intercepts. The key thing that you've got to remember is at the x-intercept, meaning when this graph crosses the x-axis. On the x-intercept, right, when we cross this x-axis, the one thing that has to be true every single time is that y equals 0. Remember, the y-coordinate literally tells you, if this is our point xy, the y tells us how far the point is from the x-axis. Well, on the x-axis, the point is 0 away from the x-axis, obviously, so the y has to be 0. And likewise, for the y-intercept, x has to be 0. Because at any place along this vertical axis, the distance from it is 0. And that's literally what the x-coordinate means, the distance from the y-axis. So specifically, we had maybe the point 2, 1. The x-coordinate tells me that we are 2 away from the y-axis and 1 above the x-axis. That's specifically what those mean. So if you keep that in mind, it's pretty easy to find the x-intercept of any equation, because to find the x-intercept, we just plug in 0 for y. So at 3x plus 2 times 0, obviously I can divide both sides by 3, and quickly see that the x-intercept here is going to be 6. I can do the same process to find the y-intercept, because for the y-intercept, x is 0, but if you look at it this way, that's all just going to become 0. I don't even need to worry about it. Solve this for y, divide both sides by 2, and I'll see that the y-intercept, sorry my scale's not very nice here, my y-intercept is 9. Now that you have 2 points on that line, if you have 2 points, you're good, because 2 points define any line, so I know the line has to look like this. So an easy way, you can literally in your head find the x and y intercepts for this line and then quickly graph it. So just remember that, really helpful when we're graphing all kinds of linear functions. Next thing we need to talk about is absolute value. You probably saw this at some point last year. Things like the absolute value of 4. It's these 2 straight lines up and down, something in the middle. And you may be thinking that, oh, I remember absolute value. Absolute value means if it's a positive number, keep it as a positive, but if it's a negative, turn it into a positive. In other words, according to your rule, this would be 4. Absolute value of -3 is 3. If that's what you think absolute value is, you're not incorrect, but you don't understand absolute value. You won't be able to use it in any meaningful ways. That speaks not at all to what absolute value means. What absolute value means, the definition of absolute value, for example, the absolute value of x, this is telling us the answer to this question, the answer is how far is x from 0. So if you're looking at it on a number line, here's 0, let's take 4. The point 4 is here. The question this is asking, the question that this mathematical notation is asking, is how far is 4 from 0? Well, clearly 4 is 4 from 0. It's a little different when you think about this. This is asking how far is -3 from 0. Well, -3 from 0 is 1, 2, 3 away. That's why absolute value is always positive, because distance is positive, length is positive. So this is asking how far is -3 from 0, which the answer is obviously 3. So keep in mind what absolute value means, and you'll be in good shape, especially once we get a little more complex. Oh, this is a biggie. Take a big breath, pause the video if you need to, get ready, because we're going to talk about point slope form of a linear equation, something that will be incredibly useful to you. We're going to start off just by talking about 2 points. Let's say we've got the 2 points 3, 5, and 5, 9. I'm pretty sure you all know how to find the slope between these, and the slope is going to be the change in y or the change in x. I can say 9 minus 5 over 5 minus 3. 9 minus 5 is 4, 5 minus 3 is 2, so the slope is 2. And, last year or 2, maybe 5 years ago, you also learned that you could put this into the middle schooler's favorite way to write a line, slope-intercept, y equals mx plus b. And the m is 2, but if you need to find the y-intercept, you can plug in x and a y. So let's do that. We'll just plug in this one. So if y is 5 and the slope is 2, x is 3, 2 times 3 is 6. Subtract 6 from both sides, and I'll find out that b is negative 1. And then I plug that back into here, so I know my equation for this line is y equals 2x minus 1. And that's beautifully done, right? That is correct. Absolutely wonderful. But let's think for a second. What if instead of being given both of these points, we were given this point and the slope? So we didn't get 2 points. They just gave us a point and a slope. Well, obviously, you could still do the same idea, right? With the point, you could plug that into y equals mx plus b, solve for b. Not hard, but a little bit of effort there. And so I'll just think about what the slope means. Remember, the slope means the change in y over the change in x. Well, I'm going to pretend that there's some other point, which there is, right? There's some other point xy that's also on this line. And I'm going to write down the slope between those 2 points. And I know the slope between them is 2, because I'm told the slope on this line is 2. So I'm going to do the same thing we did up here with x and y. I'm going to write y minus 5, right, the change in y, over the change in x, which is x minus 3. So all I did is I wrote down the slope. But instead of using the points 3, 5, and 5, 9, I used 3, 5, and xy, where xy is just any point on the line. It's going to stand for any point on the line. And this has to be true. If the slope is 2, then that is the slope between 3, 5, and any point on the line, so this is true. But notice if I wanted to, I could multiply both sides of this equation by x minus 3. So here I'm going to get 2 times x minus 3. Here the x minus 3 cancels out, and I get y minus 5. And believe it or not, we have just derived what is called the point-slope form of a linear equation. And if you really want to, we could multiply this out, distribute the 2 to get 2x minus 6 equals y minus 5, add the 5 to both sides, and no big surprise, we've got the slope-intercept form of the line. But notice, the reason this is really helpful, right? These are the same, right? This line, y equals 2x minus 1, is just another way of writing this line. Both of those are a perfectly valid relationship between x and y. But notice what we've got, if they give us a point and a slope, all I have to do is plug those things in. Right? Look carefully. The x1, this little x1 here, is the point 3. y1 is the point 5 that we were given. The slope is still simply 2. So if I'm given the slope 2 and the point 3, 5, all I have to do is write y minus 5 equals 2 times x minus 3. And I'm finished. I don't have to find the y-intercept. This is a perfectly valid equation for a line, called the point-slope form because you can immediately see the slope and you can immediately see a point on the line. Just be careful of the negative sign. Remember, this is the point 3, 5. So when you see it in general, the point-slope form says y minus y1 equals m times x minus x1, where m is the slope and x1, y1 is any point on that line. And this form becomes really useful, especially once we get to calculus. So the sooner you learn it now, the better off you shall be. That should be all you need for page 27. We'll see you in class tomorrow.